Hi, we're going to continue to talk about higher order functions, and this time about functions that can return other functions. So here I've written a few lambda functions. The first one is an identity function that just returns the argument itself. The second and third one are either double or triples the given argument. Now, these functions, and let me show that it works first. So when we double 10, that number becomes 20, right? So when we have expressions or lines of code that are very similar and only differ in a small part, then we always want to think about how can we refactor the code such that it's cleaner and we can accomplish the same thing with less code. Okay, and the answer in this case is that we can write functions that returns a function, and that is, returning a function is just kind of like returning a number, returning a string, returning any sort of data, right? But we're just returning a function. And so functions that return a function is also one type of higher order functions that we've been talking about. So remember, higher order functions do not necessarily just take functions as parameters, as inputs. They can also return functions as a result or as an output from the function. So in this particular case, looking at all these lambda functions, we notice that they only differ in the multiplier, right? So we can write a function multiplier that takes a number as a parameter, and we return a lambda function that multiply its argument or its parameter with n, the multiplier. So to write the identity function, then it is just multiplier with the argument of 1. So this 1 is assigned to the parameter n, or here then what it returns is it returns a lambda x multiplied by 1, right? So this statement basically becomes this: identity equal to lambda x and x multiplied by 1, which was basically the original definition for the identity function. So if we run this, as we surely expected, that this returns whatever the argument that we pass to the identity function. And I think you know where we're going with this, and that is to define the double function. We can simply call multiplier and give it the argument 2, and then we have a function that we can call, and this should give us 20. So it might be a little tricky, so let's go over this one more time to make sure we are on the same page. So first, we call multiplier with the 2 assigned to the argument n. So the multiplier will return a lambda function that says lambda x is x multiplied by n, which is 2, right? So double is a lambda function. And then the next step is now we call double and give it a argument to substitute in for x, and that argument is 10 in this case. So the lambda function evaluates to 10 multiplied by 2, and that's why we have a result of 20 here. So here is a little exercise for you that we also have a triple function earlier that I'd like you to write, but using the multiplier higher order function that we wrote earlier. So please pause the video and give it a try. And assuming you've done that, it should be fairly straightforward that triple is the result or the function returned by calling multiply with the argument 3. Now, more importantly, make sure you do understand how it works. And here is another little fun exercise for you. that let's try to write a function called myPower, and given the base, so it will return a function that raises base to a given exponent. So for example, myPower and 2, then it would myPower 2 would return a function that raises 2 to a certain exponent. So if we call this function again with an exponent of 3, then this whole expression would evaluate to 2 cubed, which is 8. So please pause the video and think about this a little bit and see if you can write this function. All right, so hopefully you have had some time to think about it, and here is one way to do it. Now I could write this as a lambda function using lambda as well, but in this case I want to take a slightly different route, and that is I define another function that is returned by myPower. Now what this function does is that it takes an exponent, right? Because that's what the myPower returns, right? It takes a function that takes a given exponent. So it will take the given exponent and then it raises base to that exponent. And this is, again, this function is returned by the myPower function. And if we use it now, it should give us 8. And if you need a little further breakdown of how this works exactly, we can look at the first function called myPower with the argument of 2. So that calls the myPower function, which basically returns func, right? And what func is basically a definition, a function definition with the base having the value of 2, right? So that's 2 here. Now, so this part becomes a function, and we call the function, this function now, but with the argument of 3 assigned to exp. So basically, this whole thing now is calling the function func with the number 3, and which then returns power of 2, right? That the 2 comes from here, and exp is 3, so power of 2 raised to the third power, and that's how we get 8 at the end. And I also want to point out what we did here was that we transform a function that takes multiple inputs, just like power. It takes a base and an exponent as its 2 inputs, and we transform that function into a series of functions, 2 to be exact in this case, and each of which takes a single input. So myPower takes a single input, the base, and the function that myPower returns takes the exponent as its 1 input. So this transformation has actually a name. It's called currying. So these functions that return other functions as results, I mean, other than looking kind of neat and maybe cool or perhaps a little confusing, is there any actual use for them? Well, it turns out, yes, there are. And one of the most practical use of this kind of higher order function is, in fact, decorators, such as the add class method and other decorators that we've been using. Decorators in Python, they are just implemented as functions, but they do return a modified version of the functions or methods that they decorate. Unfortunately, this is really beyond the scope of the class, but if you're interested, I have a link here to an article that explains this idea very well. So take a look if you're interested. So another really neat example of function that returns function comes from the standard package functools. It's a function called partial, which I actually occasionally use. And it's actually kind of a similar to the idea of currying that we just talked about. So what partial does is it takes its first argument or parameter, another function, and then one of multiple values, and it returns a function that's essentially the given function, but with some of its arguments already assigned. So for example, here the given function is power. Power takes two arguments, the base and the exponent. So partial returns power, but with the base already filled in, because we specify 2 here, so the base is it's assigned the value 2 here. So the function that it returns, then it will require one argument or one parameter for the exponent. So in other words, what partial returns is a lambda of exponent of power of 2 raised to that exponent. So I can assign this function to a name, say power of 2 here, and then I can use this power of 2 to calculate 2 raised to the 4th power, 2 raised to the 8th power, which I already type out here. So, and I can run it, and you can see that they produce the right answer. 2 raised to the 4th power is 16, to the 8th power is 256. So that's like I said, it's a function that I find myself using sometimes. So it's kind of really neat. Anyway, well, functools actually has other very kind of nice little neat utilities. And if you want more information, I have the link here.